Alright, so the first thing that we're going to be discussing with our physics semester is motion and speed. So to start off, you need to know what motion is. So the definition of motion is when there is an object that is changing position over time compared to a reference point. A reference point is a spot that is staying in place, some kind of object that you can look at and refer to compared to what is moving. So let's say you're watching a car drive in the distance. If there's nothing around that car, it's really difficult to tell, especially if you're far away, if that car is moving. But if you, let's say, see there's a tree or a telephone pole that's there, it's really easy to tell that the car is moving because you can tell that it is changing positions compared to that tree, which you know is staying still. So when something is in motion, you're able to see that it is changing places compared to something that is staying in place. So compared to that reference point, you can tell that it is moving. That's the definition of motion. Some reference points that are commonly used, and you can use almost anything. I mean, anything that stays in place can be used as a reference point. Also, some things that don't stay in place. We often use ones that stay in place, like the Earth's surface. So, if somebody jumps, you can tell that the Earth's surface is staying in place. They are moving. If a car is driving on the Earth's surface. Of course, we know the Earth is rotating, but in general, it's staying in place. The car is moving in relation to the Earth's surface that is staying in place. Um, Sometimes things moving by. If you have something that's moving faster than something else, such as somebody riding a bike and somebody driving a car, you can tell that that car is moving in comparison to the slower moving bike. It's changing position faster than what the bike is. Or like I said before, if you see a car passing a tree, we know it's standing in place. Somebody that's walking by, something that's standing still, like a trash can, you can tell that person is in motion because it's changing positions compared to that object that is staying in place. So anything can be used as a reference point when you're comparing to what's moving to that thing. So speed is going to be the first thing that we are calculating. Speed is the rate at which an object moves, and we're going to be creating a formula sheet this whole semester. You're just going to keep adding to it. So if you want to start it now or start in class tomorrow when we are working on these calculations, you may. But the very first equation we will have is speed. The SI unit for speed is meters per second. So we don't use miles per hour because that is the standard unit. We are working with metric, so we're going to be working with meters per second. So our calculation for speed, we're calculating average speed. So what is the average speed over the time that object traveled? So usually it's really difficult for something to go a completely constant speed the whole time. A lot of times that speed is going to vary. When you're walking, you're probably not going to be going exactly 2.3 miles per hour the whole time you're going. There's definitely going to be at least a little variation. So we find average speed by taking the total distance traveled divided by the total time. So for example, if you have a car that travels 50 meters in 10 seconds, you'd have 50 meters divided by 10 seconds. That means you have 5 meters per second. So that car traveled 5 meters every second that it was traveling. So it's a really simple equation, but we end it with meters per second as our units. One thing to look at here is we have some speed graphs and we have some time. So we're going to be doing some work where you see speed on the y-axis. So you can see here we've got speed on the y-axis and we've got time on the x-axis. So we can actually, when we talk about acceleration, we're going to look at a couple of these graphs, but we're also going to look at some with distance and time. But in this case, if I asked you how fast was, let's say a car, this is the description of how fast a car is going over time, I could ask how fast was the car going at 2 seconds. So you can see at 2 seconds, this lines up at the line right here, which means that the car is going 20 meters per second at the exact time of 2 seconds. So we will look at this example graph and we'll also look at examples where it has distance and time and we can calculate the speed at that exact time, but we're going to do some of that work in class calculations. All right, to make sure that I know that you have listened to this video, go ahead, just draw a star in the top right corner of your paper, and also don't forget to bring your 2 questions to class the day the notes are due. We're going to use that to help discuss this. So that's also going to be part of your participation grade.